In this presentation, we'll be going over the topic of the origin and adaptation of self-harm in human and non-human animals. Have you ever wondered if non-human animal species demonstrate human-like behaviors, specifically those such as self-harm tendencies and self-mutilation? Although there are parallels between human behavior and animal behavior, such as monogamous mating systems and the use of tools varying among different species, many people believe that behaviors in signs of mental trauma are exclusive to humans, but this is a misconception. Today we'll be looking at some examples of this idea, that is, self-mutilation and self-harming behaviors, their possible causes, and the specific types of harmful behaviors that have been observed among various animal species by the scientific community.
We understand that humans usually use self-harm tendencies to experience pain that relieves or distracts them from their chronic stress. The question is, how did a behavior like this originate in the first place, and what physiological processes motivate people to injure themselves? It's important to investigate both the how and why of self-injury in animals in order to better provide medical treatment for both humans and captive animals alike. In humans, self-injurious behavior is associated with childhood traumas, control issues, and other mental conditions like eating disorders, borderline personality disorder, obsessive-compulsive disorder, and general stress and anxiety. In animals, the three most common triggers that lead to self-harm include isolation, boredom, and stress. When the body feels pain, it releases hormones like dopamine, adrenaline, and endorphins, which are a combination of reward and stress hormones that give the body a jolt that spikes the blood sugar, increases the heart rate, and dilates the pupil, but over time can lead to damage of major organs in the body. Given these effects, you might start to see why this is such a common way to cope for animals experiencing difficult situations. Boredom and isolation are usually an issue for animals held in captivity, as we have seen in multiple apocalypse or movies where someone is stranded on an island. Being on your own is enough to make a person quote-unquote go crazy. Animals need company and things to do too, or they will experience a similar effect. In some cases, animals may turn to self-harm in the event of physical injury, perhaps to distract from the pain they are suffering from already present. For example, researchers observed severe self-mutilation in a 10-month-old cat suffering from several broken bones after having suffered a life-threatening accident. Cats are prone to developing a form of obsessive-compulsive disorder, in which their natural aggression towards prey becomes self-directed and can extend from over-grooming to chewing on their own body parts. But the causes of self-harm go beyond external factors like traumatic life experiences. Multiple studies have found links to chemical imbalances and neural dysfunction with self-injury in non-human species. Most observations of self-harm in humans are seen in teenagers. It's easy to believe that these behaviors are just cries for attention, since humans usually self-report their reasons for self-harm. But we can look at the underlying reasons by studying animals such as macaques and chimpanzees. In these observations, researchers can pay attention to more immediate potential neurological and physiological causes for self-mutilation. For example, researchers have looked at the changes in function in glial cells called astrocytes in these primates. Astrocytes are simply nerve cells that are ultimately responsible for transmitting electrical impulses in the brain and providing neurons with nutrients. However, deformation or any modification to their form can affect the neurological processes of the brain and animals' behaviors. These researchers found that a decrease in astrocyte complexity was associated with increased rates of self-harm in the macaques. In addition to looking at the function of brain cells, measurements of hormones can be used to better understand the motivations behind these behaviors. Glucocorticoids, which are anti-inflammatory steroids, are used as a hormonal measure for stress and its possible effect on self-harm in chimpanzees. This was done by taking fecal samples of 22 chimpanzees, 11 male and 11 female, and comparing the glucocorticoid levels to different severities of self-mutilation. Self-mutilation was measured through the amount of hair loss during the time the individuals were held captive. The results showed that chimpanzees subject to captive environments show a direct correlation between mean concentrations of these stress hormones and the different ranges of self-mutilation. These studies show that self-harm can arise due to multiple different factors, and although it's a condition we don't yet know much about and still needs much more investigation, we know that it's not exclusive to humans, and there are many possible ways to treat it. As we have seen, understanding both internal and external factors that lead to these behaviors in animals will allow us to develop the best treatments suited for human patients and help to dispel any misconceptions regarding this condition.